Hi all. Let's know it about road traffic accident.
Tia, Tia, oh Tia, you left me here. Uh, so sorry, sir. Oh no.
What do you think about this video? Is it a road traffic accident? If you're confused, let's discuss together.
Where do you think that someone can die every 24 seconds? In a war zone? In a global crisis? Or maybe in a disaster? But no, it happens in the ordinary route every single day. Here, we can project the traffic route if a disease. It can leading the cause of the deaths globally.
Can you see that the number of transport accidents had a 2.3% to cause people today? But the number of road traffic deaths in each year has not increased in the past 3 years. In 20 and 21, it was estimated about 31,000 fatalities in Indonesia due to road crashes, according to WHO, accounting for 2.0% of deaths in the country. Why it can be happened? But the answer is far more ordinary and far more preventable. So, if road traffic accidents are not random, then what patterns do they follow? And today, we're not only going to talk about accidents, but also comprehend the patterns, determinants, and how we can prevent it. But before we talk more, I want to share who is the most at risk. The first is socio-economic status, because as over 90% of road traffic deaths occur in low and middle income countries. And the second one is, of course, age, because it is the leading cause of death for children and young adults aged 5 until 29. And the last one is sex, because males are 3 times more likely to be killed in the road crashes than females. Yeah.
In epidemiology, the causations can be multifactorial. Road traffic accidents can occur due to human factors, environmental factors, psychosocial factors, and what we call precipitation factors. Now, let's take a look at the example of road traffic accidents.
Hold on. Based on the 3 videos provided before, let's analyze of why this accident occurred and the factor that influenced them. The first is luxury sport car crash. Why it accident can be happen? Because this incident was caused by impaired judgment and lack of technical skill. The driver attempted a high-speed turn and intersection, but because he was intoxicated, he could not manage the vehicle high superpower. And the influencing factor divided into two major factors. There are substance abuse and inexperience. The alcohol severely impairs motor coordination and the ability to judge speed. And additionally, because the driver never had a license, he lacked the training to handle the torque of a luxury sport car. When he accelerated too hard during the turn, the tires lost traction, causing the car to whistle uncontrollably into oncoming traffic. In the second video is about truck crash. What it can be happen to? Because this accident was triggered by a sudden lane intrusion. A passenger vehicle cut directly into the path of the semi-truck, forcing the truck driver to make an emergency evasive maneuver. And what the influencing factors? The primary factors here is momentum and mass. Due to the immense weight of the semi-trailer, the sudden sharp turn caused the vehicle to lose stability. On a narrow bridge with limited runoff space, the true kinetic energy carried it through the guardrail, leaving it dangling over the river. The highlights the critical needed for the passenger vehicle to maintain a safe following distance around heavy machinery. And the third video is about the animation about distracted driving. This accident happened due to cognitive and visual distraction, right? The motorcyclist was focused on his mobile phone and was further distracted by a pedestrian, leading him to drive blindly into the back of the stationary or slowing vehicle. And the influencing factor is delayed reaction time. Research showed that using a phone while driving reduces a driver's situational awareness by as much as 35%. Because the rider's eyes were not on the road and his mind was on the conversation or pedestrian, he failed to perceive the hazard in time to apply the brakes. Okay. So the conclusion, the concrete reasoning behind these three accidents boils down to human error. Whether it is the unpracticable behavior of others, or voluntary distraction or criminal negligence, each case demonstrates a failure to respect the physique of the vehicle and the rules of the road. Safety is compromised the moment a driver's attention or sobriety is removed from the equation. Okay, so let's talking about the Haddon metric. The Haddon metric provides a comprehensive framework from understanding these three accidents by breaking them down into the chronological pace of a crash and the contributing factors involved. In the pre-crash phase, or from humans, is the primary trigger in every scenario. From the truck, the driver was a victim of another driver sudden lane intrusion. From the animate motorcyclist was blind by mobile phone distraction, right? And from the driver in the car is the driver was incapacitated by alcohol. During the crash phase, the focus shifted to energy transfer and injury prevention. In the truck, the vehicle cabin integrity and the driver's seatbelt were the agents that saved a life, whereas the guardrail or environment failed to contain the truck's massive kinetic energy. In the contrast, the animated crash highlighted the extreme vulnerability of a motorcycle. Without a protective shell, the host absorbed the full force of the impact against the hard asphalt. In the car crash, the luxury car's advanced safety feature, like airbags and crumple zones, likely mitigate the impact of the drunk driver, even as the vehicle's speed caused significant damage to the oncoming SUV. This phase demonstrates the while human error started the crash, the mechanical engineering of the vehicle and the design of the road determine who survived. In the post-crash phase, the outcome is determined by the efficiency of the response system and the legal environment. The truck is the prime example of successful environment response, where specialists emergency crews perform a high-stake rope rescue to pull the driver to safety from the dangling cab. In the video animation before, the result is a grim reminder of medical limitation with high-speed trauma occurs without protective care, often leading to fatalities before help arrives. Then finally, the social and legal environment plays a role in the car, where police intervention and pre-hazard tests ensure that the host faces the consequence of criminal negligence. Finally, the social and legal environments play a role in the car accident, where police intervention and pre-hazard tests ensure that the host faces the consequence of criminal negligence. So together, these three cases illustrate that road safety is a balance between human behavior, vehicle physics, and forgiving infrastructure.
The scenarios that we represent is really simple and very ordinary, even with the daily life of the students, like riding the motorcycles, and then with the shorter distance, with the familiar routes, it also can be represent or contribute to the road traffic accidents. So we can clearly see that the RTA is not really random because there are a human, environmental, psychosocial, and precipitation triggers that really contribute to it. And this is remind us that road trip accidents can be a preventable event. And remember that you are not alone in the road, because sometimes the accident you survive may become someone else's trauma.
Have you ever wondered why workplaces like industry often happen accidents? Are they just unfortunate events, or are there underlying factors that we often overlook? Imagine a factory worker getting injured by a machine. Was it purely human error? Or was there a lack of training, safety procedures, or maybe a protective equipment? The situations may look like a random incidents, but are they really unavoidable? Or are there hidden factors that we often fail to notice? Therefore, let's learn more about industrial accidents and how epidemiological approach can help us analyze and prevent them. A worker is standing near a loaded pallet that is being handled by a forklift. He is holding onto a vertical support of part of the load while the forklift's forks are inserted underneath the pallet. At some point, the worker steps forward into a dangerous point right in front of the load and between the forklift forks. Unfortunately, his foot slips and gets caught between the two forks. At the same time, the forklift operators begin to move backward, unaware of the workers' positions. As the forklift reverses, the worker is pulled along and losing his balancing and falling into his back. A large industrial tank was being filled with water for hydrostatic testing, a process used to check for leaks and structural strength. At the same time, two mechanics were working near at the top of the tank, using angle grinders to polish the handrails. Meanwhile, the operator started the testing process by pumping water into the tank through a pipeline. However, unknown to the team, the pipeline still contained leftover gasoline from previous use. As the tank filled, the gasoline entered and floated on the top of the water. Due to high temperatures, it evaporated and formed flammable vapor. While the mechanics continued their work, sparks from the angle grinder ignited the gasoline vapor, causing an explosion that injured both workers. An explosion forcefully threw the workers against the handrails at the top of the tank. They lost their balance due to the impact of the were unable to protect themselves. The suddenly blast created and dangerous chaotic. The first cause was the failure of properly clean and purge the pipeline, allowing gasoline residue to remain in the system. The second was the presence of hot work activities near in confined area that containing flammable fiber, which provided direct ignition sources. Another contribution factor was the lack of the proper isolation during the hydrostatic testing process, as the workers were still allowed to remain on the tank. In addition, there was a poor coordination and communication between the teams, as different activities were carried out simultaneously without fully understanding the risks that involved. Lastly, the absence of the strict safety procedures and hazard assessment allowed these multiple risks to combine, ultimately leading to the explosion. A worker was operating a machine, focusing on his tasks with his hands positioned close to the moving parts. The worker approached the machine from the front, unaware that it was already in use. A worker approached the machine, but before operating it, he carefully checked the surroundings and heard unusual movement from inside the machine.
Hey, is somebody working on this machine? I'm cleaning back here.
He stopped and did not activate the machine. A worker walks out of the railway and heads toward the stair. He falls toward hitting the ground head first from a height about 1.3 meters. A worker is walking through the area, unaware of a leaking pipe nearby. Liquid has spread across the floor, creating a slippery surface. As he steps onto it, he suddenly slips and falls backward onto the ground. A cable left lying across the pathway. He trips over the cable and falls on the ground. In order to protect the workers, let's prevent similar incidents. Pathways should always be kept clear and accessible for everyone. For sleep hazard, it is important to conduct a proper risk assessment and implement the safety measures. Ensure there is a good light in the stairways, corridor, and entrance. Maintain steady handrails and good visibility. A worker is performing a task at 8 using a scaffold. He appears to be reaching for equipment placed nearby while a bucket of water sits on the platform. As he shifts his positions, the scaffold becomes unstable and begins to shake. Without the proper protections, he loses his balance and falls from the platform. Don't forget to secure your safety harness because one small step can prevent a life-threatening fall. In a construction site, a lifting operation is being carried out to move a heavy concrete load, weighing approximately 4 tons. However, the task is handled by a worker who is not properly trained or licensed to operate the lifting equipment. As the load is lifted, it becomes unstable and begins to tilt to one side. The operator struggles to control the movement, causing the load to swing unpredictably. Then suddenly, the load slips from the positions and falls. To prevent incidents like this, proper training and certification are essential for anyone involved in lifting operation. All workers must stay at safe distance and avoid standing under or near suspended loads. Warning signs and barriers should be used to restrict access to dangerous area. The effective communication between workers is also important. Already exists due to unsafe worker positioning and the absence of a safety zone. During the event, the interaction between forklift movement and limited visibility increases the risk of injury. In the post-event cases, the lack of an automatic stop systems and emergency response worsens the outcome. The metric indicates that before the event, risks arise from the poor coordination and an unsafe environment with residual flammable materials. During the event, the interactions between hot work and gasoline vapor triggers an explosion. After the event, the absence of the evacuations and emergency systems increases the injury. The metrics show that in the pre-event phase, risks arise from a lack of communication between workers, the absence of lockout systems, and a warning sign in the environment. During the event, the machine is activated unintentionally, creating a hazardous interaction due to unsafe working proximity. And then in the post-event, the inability to react quickly combined with the absence of an emergency stop and immediate assistance that increase the severe injury. In the pre-event phase, the risks stem from low awareness and industry keeping condition. During the event, contact with a slippery surfaces or obstructions leads to a fall. In the post-phase, injuries are aggravated due to the lack of immediate hazard control. The metric highlights that before the event, the absence of fall protections like helmets and unsafe work conditions create a risk. During the event, loss of balance and unstable equipment lead to a fall, and after that, the lack of fall arrest system risks increase the injury severity. In the pre-event phase, risks are linked to an untrained operator and the absence of a restricted area. During the event, the unstable load falls and creates a direct impact. In the post-event phase, the absence of emergency response prevents the effective injury mitigations.